Okay, this is actually called, the section's called Probabilities of Compound Events. If it was me, I would change the title to like Probability of Mutually Exclusive and Mutually Inclusive. So basically on that handout, let's go through the examples. It says for probability of a mutually exclusive, it says if in a single trial the occurrence of one event prevents the occurrence of any other event, the probabilities are said to be mutually exclusive. So if I take a single die, and if I roll that die, rolling 2 on that die prevents me from rolling any of the others, right? Okay, so those are mutually exclusive, okay? And that's their example here. If you, in throwing a die one time, the occurrence of the 3 prevents the occurrence of the others, hence they are mutually exclusive. Okay, if I roll this die twice, rolling a 2 on this one does not prevent me from rolling a 2 on the next one. Okay, so those are not exclusive. Okay, and basically that's what they're saying. Okay, in the first trial, it would not prevent the occurrence of any of the others in the second trial, so those would not be mutually exclusive. Okay. If a number of events are mutually exclusive, the probabilities that either one or. Now, here's where I want you to start highlighting. Keywords on these, the or. Okay? The either or. If in a number of events are mutually exclusive, the probability that either one or the other will occur in a single trial is the sum of their separate probabilities. Okay, so let's look at an example. Suppose a coin purse contains 5 nickels, 6 dimes, and 2 quarters. What's the probability of selecting a nickel? Now, when you read these problems, keyword is or. Okay, so highlight that. What's the probability of selecting a nickel or a dime? They cannot be both at the same time. Okay, it's either one or the other. It's either a nickel or a dime. So when we did probability, you're still doing the general formula for probability, which is success over success plus failure. So if you look at this, what's the probability of selecting a nickel? Okay, you got success would be 5 nickels out of how many total? 13. So this one is the probability of selecting a nickel, 5 out of 13. Then what's the probability of selecting a dime? Well, success, there would be 6 of them. Total coins, success plus failure, 13. And it's the sum. Okay, so if they are mutually exclusive, you're going to add those two probabilities together. Okay, so final answer, 11 out of 13. Okay, so mutually exclusive, you're going to look for the keyword or, and you're going to add their probabilities. Okay. If two events, now this is what it would look like if you were actually working in a statistics book, okay, statistics and probability. If two events A and B are mutually exclusive, the probability of both events occurring is, okay, so they're going to write a probability of event A or event B equals the probability of A plus the probability of B. So that's what the formula would look like in a statistics book. Okay, and I put out here, there's no point in common. You can't have, it can't be a nickel and a dime at the same time. Okay. Okay. Then there's a little separator there. Let's look at another example. What's the probability of drawing a king or a black card? Still another key word, or. But now you've got to think about a deck of cards. Okay. Kings, there are 4. Black cards, there are 26, right? There's 13 clubs, 13 spades. But how many black kings are there? 2. There is a point in common, mutually inclusive on this one. Okay, so these are inclusive. There's a point in common because there are black kings. Okay, so you still add, figure the probabilities that there are kings. How many kings are there? 4. Total cards, success plus failure, 52. How many black cards are there? 26, and success plus failure is 52. And we're adding those. But within those two, we actually have an overlap, because we've included all 4 kings, and we've included all the black cards, but within those we have an overlap of 2 black kings. Okay, so that's why you've got to subtract the overlap. You subtract the point in common. Okay, there were 2 black kings, in total success plus failure is 52. So you've got to add the first 2 and then subtract and then reduce. Inclusive, yep. And you would subtract the point in common, yep. Okay, and this for inclusive, the only difference here is you're going to subtract the point in common. So it's still probability of A or B, and it's the probability of A plus the probability of B, and then you subtract that point in common. So you've got the 1 point in common. Okay, and we've already talked about odds in favor, success over failure, and odds against, failure over success. So main thing when you're reading these, instead of, like before we were actually multiplying probabilities on some of those, now you're going to look for the keyword or. If it's mutually exclusive, you're going to add the probabilities. If it's mutually inclusive, you're going to add and then subtract the point in common. Okay? Good? Okay.